Hello and welcome. In the next few minutes, we're going to deep dive into connecting Google Cloud VMware Engine workloads to Google Cloud Filestore. I'm Daniel Patterson, a senior multi-cloud architect at VMware, and let's get started. So first, let's talk about what you've already deployed. I expect that you've got an existing VPC network, in this case, the GCVE Peered VPC Network. You've configured private services access to Google Managed Services, and you've established the GCVE Private Connection to your Private Services Access VPC network. You may already be consuming Google managed services like Cloud SQL or Cloud Build via private services access, but FileStore is not deployed in the same private services access VPC network, and this creates a few nuances for GCVE. Instead, FileStore is deployed in its own Google managed VPC network and requires its own private services access peering connection. Today, we'll deploy our file store instance, but we'll also deploy Cloud Router and Cloud VPN instances that will provide connectivity from GCVE through a transit VPC network that we'll also deploy today. We'll establish a BGP session between our Cloud Router instances and validate that we can connect to our Cloud File Store instance from a workload running in GCVE. Now, you're likely wondering, why can't we simply connect to Cloud File Store without using a transit VPC? Without the Transit VPC, the new FileStore VPC network would be peered directly to the existing GCVE peered VPC network using VPC peering. These VPC peering connections are not transitive. Routes learned from one VPC peering connection are not advertised to another. We're using the Transit VPC and cloud routers to get around this. There is an additional cost associated with this topology, and it's a bit cumbersome to deploy. However, if you have an existing file store instance and need GCVE workloads to access that file store, this is a good solution. Now let's move on to the deployment. Okay, let's start by creating our transit VPC network. I'm going to create this in the same project that my existing VPC network is in, but you could create it in a separate project. You'll have to create a subnet for this transit VPC network. We won't actually use the subnet, but you'll still want to make sure that it doesn't conflict with any of your existing subnets. And I chose US West 2 because my GCVE instance is also in US West 2. All right, our transit VPC is finished, and you'll see we also have two other VPC networks. We'll only use one of these. The MCA VPC demo will be our existing VPC. Let's go take a look at the peering connections for the new transit VPC that we just created. Notice, since it's a new VPC, we don't have any peering connections. So let's go create our file store instance. We'll give it a name. We'll select a region. In this case, we'll go with US West 2 again to keep data transfer charges low. We'll select our transit VPC as the VPC network for the connection. We'll want to choose a custom IP range, otherwise Google will choose the range for you and it may conflict with your existing subnets. And we'll name our file share, and then we'll allow our GCVE workload to connect. In this case, I've got a virtual machine running in GCVE already, and I'll pull the subnet and put it in the allowed list. Okay, our file store demo instance is created. In real time, that took a couple minutes. Let's go take a look at our transit VPC peering connections now. So we have a peering connection. Notice we don't have any private connections to services. This just shows up as another VPC peering connection. And let's go take a look at the routes associated with the two VPC networks that we're going to be working with today. So the transit VPC, we've got a route to our file store subnets, as well as the local subnet that we defined. And let's go take a look at the existing VPC network, in this case, MCA VPC demo. This is the one that's paired with GCVE already. Notice that it does not have a route because it's in a completely separate VPC. So we'll build the connectivity to allow that now. I mentioned the deployment of the Cloud Router and Cloud VPN instances can be a bit cumbersome because you've got 4 devices and 4 VPN tunnels and 4 BGP sessions. So I created a Terraform plan to make that a little bit easier, and I'll include that plan in the description of this video. In this case, I uploaded the plan to Google Cloud Shell, and I'm using the built-in editor to make some changes. Earlier, I used a different VPC network name, so I'll change this to the name that we used for this demo. All right, let's jump into Cloud Shell and run this plan. So that's finished. Let's go take a look at the resources that were deployed. So we have 4 Cloud VPN instances, and let's go take a look at what routes were created. So if I search for my Cloud Filestore subnet, I see that I still only have it listed in the Filestore Transit VPC. So the Cloud VPN and Cloud Router instances are not sharing that to the existing VPC. This is because by default, the cloud routers are only going to advertise routes for the VPC network, not routes that are learned via VPC peering. So we'll go to our Cloud VPN instances and navigate to our cloud router, and then edit the cloud router configuration to advertise a custom IP range. In this case, since we're in the cloud router that's attached to the Filestore Transit VPC, we'll want the cloud router to advertise the Filestore subnet to the BGP peers in the existing VPC. And we'll refresh our route table, and we'll see that the MCA VPC demo VPC network now has routes for the Filestore instance. Notice there are 2 routes because we have 2 tunnels and 2 BGP sessions. Now, what about return traffic? The Filestore instance needs to know how to get to the workload that exists in GCVE. So if we look at these routes, none of them match the subnet that our existing GCVE workload is on. So we'll do the same operation, but in reverse. We'll go to the cloud router instance that's associated with the existing VPC, and we'll advertise a custom IP range, but in this case, it will be the subnet associated with our GCVE workload. And now if I refresh, we've got our 2 routes. Now let's connect to our Cloud Filestore instance. I'll pull up the command line for our GCVE workload and mount the file share and create a test file. And then let's add some data using DD. And we'll do that a few times to get some activity. And notice it's all working, but there's really not a great way in Cloud Filestore to see anything about operational activity. So let's go to Google Cloud Monitoring to take a look at that. Go to Metrics Explorer, and we'll find the Filestore instance, and then we can select any of the metrics that we want to look at. So we can see we've got some used bytes that have increased as we've added data. We'll add a little bit more data, and then we'll go take a look at bytes written to get something that looks a little more interesting. All right, that's it. So this topology uses production-ready Google managed services like Cloud Router, Cloud VPN, and VPC peering to provide highly available, easy to manage connectivity to your Cloud Filestore instance. Future versions of Cloud Filestore or Google Cloud VMware Engine might make this topology less complex, but if you have an existing Cloud Filestore instance today and need to connect your Google Cloud VMware Engine workloads, this is a good path forward. Check the video description for more information and ways to provide feedback. We'd love to hear from you and hope this has been helpful.